Good afternoon everyone, I am Mr. Ish. Thank you for joining me for this video, a useful one. We are looking here how we can graph polar equations, and the technique is simple. You're going to basically cheat your way through this by converting a polar equation to a rectangular equation. Then you will graph that rectangular equation and you will have your graph. The procedure is not difficult. Polar equations are those which are in the form r is equal to something or theta is equal to something. Here r implies radius, theta implies a certain angle in radians. When you're looking at rectangular equations, these are your equations in the x and the y form, x plus y, y minus x. That's what rectangular equation is. You have your x and the y variable represented clearly. Polar equations are r equals or theta equals. Then obviously you can graph it. Let's look over here at the procedure. Your procedure is by means of three different types of equations. You have one is tan theta is always equal to a y over x. Think about it. You know this from trigonometry. Tan theta is always equal to opposite over adjacent. That's what it is. That's one of your methods for converting a polar equation into a rectangular equation. You also have your unit circle equation, x squared plus y squared is always equal to r squared. Then you have your two parametric equations which come from a unit circle, and you can easily demonstrate this. X is equal to r cosine theta is one of them, and then y is equal to r sine theta, and you can easily derive both of these from this unit circle. Before we actually look at our three questions, look over here. I have a unit circle or part of it. I have a certain point here P which has a certain x and a y. I can extend from a certain angle a radius, and then I can bring it down and create a right triangle. Here's my radius, here's my x and my y. If I want to determine the x, I know cosine theta is equal to adjacent over radius, and then x is equal to that. And I know sine theta is equal to opposite over radius, and then y is equal to that. That's how these equations come about from a unit circle. You know tan of any angle is equal to opposite or adjacent, hence this equation comes through. Everything here from a unit circle. Polar equations to rectangular equations, then we graph it. Our first polar equation is this r is equal to 3. What does it mean? It's a polar equation, but how do you graph it? Convert it into a rectangular equation. How will we convert it? Look at what we have over here and use what is best available for you for your conversion. I know radius is equal to 3. It doesn't help me to use this, nor that, but it certainly helps me to use this. And I'm looking here at an x squared plus y square is always equal to some r square. But if I know r here is equal to 3, it's equal to 9. And now I know that this polar equation r equals 3 is representing a rectangular equation which is indeed a unit circle with a radius 3. This here will be 3 comma 0, and this here will be 0 comma 3, and you can easily determine these. Minus 3 comma 0, 0 comma minus 3. Your first question was r is equal to 3. It's a polar equation. We converted it into a rectangular equation, then we graphed it. It's a unit circle, and it will be correct. Our next polar equation is this. Theta is equal to pi over 4. Now what can I use from these items? I have one item here, one here, and these two. What I can use is this over here. Tan theta is equal to y over x. So then I bring the angle of the theta into that definition. Tan of pi over 4 is equal to y over x. Tan of 45 is equal to 1. 1 is equal to y over x. Push this over here. I know y is equal to x. This right here is my rectangular equation. My polar equation was this. We converted it into a rectangular equation. You know the graph of this. It's easy. It's y equals x right over here. That's what it is, and the graph has been done. Keep in mind, when you're looking at your polar equation graphs, you would normally have a x and y plane, but you would also have your radii demonstrated. As you can see, this would be radius unit 1, radius unit 2, radius unit 3, or you can have everything here in terms of radius or angle. But this here, on this type of grid, you can generate this line here for y equals x. This y equals x is also equal to or synonymous with theta is equal to pi over 4 graph. Both of these are representative of what you see over here. Just you have to be familiar with looking at the polar Cartesian system, which has these circular grid lines. This right here will be the last question. I have a polar equation. R is equal to 3 secant theta. It is a polar equation. Radius is equal to 3 secant theta. Now looking at these items over here, which are your tools available for doing the conversion, what is most applicable? Maybe you want to focus on one of these two. If I know r is equal to 3 secant theta, it looks kind of similar to that. Let's try to bring it into play. I have r is equal to 3 over cosine theta because cosine is the reciprocal of that, just as that is the reciprocal of this. These two equations are equivalent. I can push this over here. Now when I'm looking at that, I have r cosine theta is equal to 3. Now when I look at this, it looks very much like this equation right here. X is equal to r cosine theta, except here r cosine theta is equal to 3, which means this value 3 is equal to x. So certainly what I'm saying is x here is equal to 3. This becomes my rectangular equation. I started here with a polar equation. I've converted into a rectangular equation by means of this parametric equation. R cosine theta is equal to 3, but r cosine theta is always equal to x. Therefore x is equal to 3. You're using your properties here. As you know, x is equal to 3 is our equation. When you rewrite it, you can say x minus 3 is equal to 0. But anyway you look at it, if you look here at your grid lines like that, but if you look at your x and y, you're looking here really, here's my unit 1, here's my unit 2, here's my unit 3. I'm really looking here at a vertical line. X is equal to 3. But this x is equal to 3 is also the same graph of r is equal to 3 secant theta. That right here represents the graph of this polar equation, but also of this rectangular equation. Keep in mind polar equations are r equals or theta equals, and keep in mind rectangular equations are expressed in terms of x's and y's, but the theta is not seen because that's a parameter. The parameter has been removed. If you look at all of these three equations I presented and you look at their rectangular equations, you will not see the theta variable because it has been removed by the procedure of conversion. You have here a theta, that's your parameter, and you can also remember that. The theta here is your third variable or your parameter, and by eliminating this parameter using one of these mechanisms over here, you convert your polar into your rectangular equation. Thank you for watching. Have a good day.